Hello, this is Michael Young on the subject of AP Statistics. Recently I got a assignment from my AP Statistics teacher on simulating a poll, and I was supposed to use this applet right here to simulate a poll. I will read the problem so that you can make some sense of it. A recent poll showed that about 73% of married women agree that their husbands do at least their fair share of the household chores. Suppose that this is exactly true. Choosing a married woman at random then has the probability of 0.73 of getting one who agrees that their husband does his share. Use your calculator or software to simulate choosing many women independently. You can use the What is Probability applet at this website, which is right here. Not this part, it's this part, but she wanted us to choose this. Anyway, to do this investigation. The applet is set up to simulate flipping a coin, but you can also use it for our purposes here. You'll specify the probability of success as getting ahead, see right here, in the applet. You will vary the number of trials, okay? Software allows you to simulate many independent yes, no, or head tails trials more quickly if all you want to save is the count of yes outcomes. The keyword Bernoulli simulates an independent. Yeah, I don't really care. Anyway, alright, we're going to start with the hardest part to show why the program that I made is so necessary. Okay, and I'm also going to explain why I need it and why it's actually faster. Alright. Here is number 5, which is, I thank God that I don't have to do this. Now simulate drawing 320 women. Okay, I'm going to tell you something right now. This program only allows me to choose up to 40 women. It doesn't allow me to choose 320, only 40. So that means I would have to run this program 8 times in order to get my result. Now, here's where the next part comes in. The probability is 73%, and okay, do this 100 times. So I'm going to have to simulate doing 320 women. So that's 8 right there. I'm going to do that set of 8 100 times. That's 800 times. I'm sorry, but I I just really don't like doing that stuff. So that's why I made this program. Alright, do this 100 times and record the percentage who agree on each of the 100 draws. And this won't even... I'll get to that later. Make a histogram with percents, which I will have to do no matter what on my own without the program. So anyway, here we go. We are going to toss and show the... Oh, sorry, we have to reset that because it didn't start the right thing. There we go. It's right here, 0.73. We toss it 40 times. Start tossing. As you can see, it goes pretty slow, and here's the reason why. You see this graph, you see these animations, and you see all this. This takes up a long amount of time. And displaying all of this, if I were to eliminate half of this, I could speed it up, and that's the reason why I decided to make a program instead. Okay. Anyway, so we will go into the actual file, which is right here. And as you can tell, here's my program. It took me a while because I gotta admit it's been a while since I wrote a Java program. I last wrote a Java program in sophomore year. I'm now a senior. For those of you who aren't in this class and like to waste your time watching educational videos on YouTube. Anyway, so here's the program. For those of you who can't even understand Java, who may not be watching this, right here, these double slashes, they indicate what is actually being done for the most part. They don't actually influence the actual program. Yeah, so that actually just tells you what's happening, so you can get some sort of an understanding. This got cut off, but I can't expand it, so I'll just show you right here. All that. So, anyway, this is all of it right here, and we'll extend so you can see some more. If you ever want to copy this or do whatever you want with it, feel free. I really don't care the way I see it. If it makes your life easier, go for it, which is why I made this program. So, going back to the top, I will now show you the actual program being run. I know my name is not Shara, that is my mother's name. she's the main user anyway. We'll start by compiling. So we have to get into the folder called Documents. Wow, I suck at typing. And then from that folder, we will go to Java files. Basically, you don't really need to know about this. If you know or understand it, good for you. Otherwise, it really has no meaning and or effect on the program. It's just allowing me to get through the files to the actual program, which I showed you before. And I'm going to compile it. That's what Java C does. I'm going to Java compile probability simulation .java and enter. Compiling and compiling and compiling, and my mouse was having a seizure for a couple seconds there. Okay, and we're going to run Java program probability simulation. Enter. And it still sees it. As you can see, I entered in some spaces in here, this whole area. This isn't what's normally supposed to happen. I put some spaces in there so that I can separate from the area where I'm compiling the actual program, so it just looks nicer. Of course, you don't have to worry about this, only I do, and it just makes my life easier. Is another reason why I'm happy that I am not you. Sorry for being so blunt about that, but it's true. Okay, here is where I enter the number of simulations desired. This is going to tell me, well, we'll go back to the other program to show you what I mean by that. See this, tell us 40 times. That's what's going to be used in place of it. See, simulations desired. But unlike that program, I can enter as many as I want. But here's where it gets amazing. You see this right here, this 40? Okay, that is the sample size. I have a separate thing for that. So I can take this right here, this will mean nothing. I can run this set of 40 100 times. So that's what this actually is. This is the 100 is running this whole simulation 40 times. I don't know how that's going to help you, if you can understand that better, but anyway. I'm going to run the simulation only 50 times, because after 100 times, I don't know if you can see this, but there's only a certain amount of space that I can use to display my program. So I'm only going to do up to 50 times, because after that, you won't be able to see the whole thing in all its glory. Okay, sample size. This is the actual 40 right here. Except if you remember, the actual problem said now simulate drawing 320 women. I get to do that instead of doing 48 times. So I can do the 320. Doesn't matter. Okay, enter the probability of success for each event as a percent. That is this. Except I would, instead of entering it in 70.73, I would enter it in 73. It's 73% probability of success. So anyway, 73% probability of success. And now I hit enter, and the program finishes for me because I am amazing. Anyway, here is what the actual program outputs. As you can see, I put simulations 50, and if you go down, we go from 1 all the way to simulation number 50. That's it. Okay, now this shows the amount of times the event happened, how many times it didn't happen, and each of those are out of the 320 right here, sample size. Okay, and I also figured out the probability of success so that I don't actually have to do it on my own. So this actually just makes my life a whole lot more easy. And yeah, as you can see, it varies for each one, as it pretty much should, because they're individual simulations. Even though they have the same probability of happening, if you toss a coin 5 times, the probability that each set of 5 times will be equal is very unlikely, as you can see by this. But the probability should come out to a number around the 73, which it does. You can see 74, 75, 70, 76. 65 is a little bit out there, but if you keep on going down, you see 73, 72.8, 72, 73, 76, 70, 69. I can't read anymore. But anyway, you get the point. I just like making my life easier, and so I did this. And if I wanted to, which is the amazing part of this, I'm going to run this program again. I can use it for other projects. I don't have to just choose this. So let's say number 3. Simulate 100 draws of 20 women. Well, again, I can't do any more than 50, but I can run the thing a second time. So we'll say 50 simulate 50 draws of the 20 women with the same probability, because it remains the same, of 73. And we'll hit enter, and you can see it's different numbers. It still gives me the probability. As you can see, it's actually the probability difference, the standard deviation, I believe. And if I am not correct, I will definitely hear it. I will definitely hear the complaints from other people in the class on how stupid I am. But anyway, as you can see, like you even have like 0.9, so that's 90% deviating away from 0.7. That's a pretty big deviation because you're changing the sample size. But yeah, this is my program. I just wanted to show this to the class, and I actually got credit for it, so that was pretty nice. If you're actually watching this YouTube video and you're not in my AP Stat class, I will assume that you like watching educational videos, but who doesn't? I would definitely say go ahead and copy my program. Power to you. I would actually like that. I mean, it works pretty much completely fine. I will end this video right here before I continue rambling on anymore. And with that, I shall say goodbye.